Do you remember our last lesson on conic sections?
About general and standard form equation of conic section. Yes, of course, but I'm also wondering how we will graph flat conic section on Cartesian plane.
Don't you worry, Miguel and Ira, because that's going to be our lesson for today. The lesson for today is graphing conic section. Our objective in this lesson is to graph the conic section in our Cartesian plane. Can you still remember the parts of Cartesian plane? It is used to determine the position of the point in the Cartesian plane. There are two axes. One is the horizontal axis, called the x-axis, and the other one is vertical axis, which is called the y-axis. Intersect is called the origin.
So ma'am, how do we graph conic sections?
That's a great question, Ira. Graphing conic section involves plotting the curves defined in quadratic equation. So now let's move on to our real target. We have 4 different conic sections, and each one of them has multiple formulas.
But ma'am, isn't that too hard? There's only 4 conic section. But each one of them has multiple formulas. My brain can handle all of that.
Lower your voice, Miguel, and have some respect for Ma'am Jesta.
It's okay, Ira. Thank you. Since you guys said that the lesson is hard, I'll be showing you a video presenting my 4 favorite professors. They will explain your lesson so much easier.
Do you need help graphing the circle? I'm Professor Lorraine and I'm sure that I can help you solve and graph the circle. Example number 1. Quantity of x plus 2 squared plus quantity of y minus 3 squared equals 25. Step 1. Identify the center of the circle. The center of the circle is 2 and negative 3. Step 2. Identify the ranges of the center. The ranges of the center is r equals square root of 25 or approximately 5. Step 3. Plot the center and the other points. Plot the point 2 and negative 3 on the Cartesian plane. This represents the center of the circle. From the center point, count 5 units in all directions to mark the points that lie on the circle. Step number 4. Draw. To draw the circle, connect the points you mark on step 3. Step 5. Label. Example number 2. Quantity of x minus 1 squared plus quantity of y plus 4 squared equals 16. Step 1. Identify the center of the circle. Step 2. Find the radius of the circle. Step 3. Plot the circle and other points. Step 4. Draw. Step 5. Label. And that's how you solve and graph the circle.
Are you having problems graphing the ellipse? This is Professor Junel and I'll teach you how to master graphing the ellipse. In graphing the ellipse, we need to look for the major axis, minor axis, foci, and the center. In getting the value of foci, use the formula square root of a squared minus b squared. Let's begin with example number 1. Quantity x plus 2 squared divided by 2 squared plus quantity y plus 3 squared divided by 3 squared equals 1. Step 1 is to classify the graph. Is it horizontal or vertical? To know this, look at the equation. If the larger denominator is under quantity x minus h squared, then it's a horizontal ellipse. If the larger value is under quantity y minus k squared, then the ellipse is vertical, which in this case, it's a vertical ellipse. Step 2, identify the center. Our center is 2, 3. Step 3 is to find the value of a, b, and c. A is 2, B is 3, and C is 1/2. To find the value of C, we just need to use the formula earlier. From the center, measure 2 units up and down along the y-axis. Then measure 3 units left and right along the x-axis. On step 5, using the points we plot, draw a smooth oval shape connecting the endpoints of the major and minor axis. Then lastly, step 6, where you label the center, the distance to the endpoints. Now, let's move on with another example. Quantity x minus 2 squared divided by 9 squared plus quantity y minus 3 squared divided by 4 squared. Same as the other example, classify the graph. This time, the larger denominator is under quantity x minus h, which makes this a horizontal ellipse. Then step 2, identify the center. Now that we have the center, let's find the value of a, b, and c. Now let's plot the center. Plot the major and minor axes to draw the ellipse. Then lastly, step 6, label the center, minor, major axis of the foci. See, graphing the ellipse isn't that hard.
I trouble plotting the given on the Cartesian plane because it's a parabola. Well, I'm here to help you do that. Graphing a parabola. What do I look for? First, the vertex. Second, the focus. Third, the endpoint of Plato's rectum. Example number 1. Quantity y minus 1 squared equals negative 16. Quantity x plus 3. Let's proceed to step 1. For to determine the direction, we're just gonna look for the first term. So y minus k. So the opening should be left or right. We're gonna solve for 4p corresponding to negative 16. So we're gonna divide it by 4 both sides to cancel out the coefficient of p. So p equals negative 4. So the opening should be open to the left. So step 2. Identify the vertex. The vertex is negative 3 and 1. Step 3. Determine the focus in the latus rectum. So we're gonna use the formula of focus h plus p comma k. So let's simplify. Let's substitute. Negative 3 plus negative 4 comma 1. Let's simplify. Negative 3 plus negative 4 equals negative 7. Just copy the 1. So 8. So latus rectum, we're gonna use the formula h plus p comma k plus and negative 2p. So we're gonna use the positive sign first. So let's substitute negative 3 plus negative 4 comma 1 plus 2 quantity negative 4. So let's simplify. Step 4. So we're gonna plot the vertex and the other points. So h equals negative 3. So we're gonna move into number 3 sa left. Then k equals negative 1 and move 1 upward. So that's the vertex. So the focus is negative 1 and negative 7 and 1. So we're gonna move 7 to the left and move 1 upward. So that is the focus. So sa latus rectum is negative 7. We're gonna move 7 to the left and move down 7. So the other one is negative 7 and 9. We're gonna move 7 to the left and move 9 upward. So that's it. So let's proceed to step 5. So step 5 is gonna draw the parabola. We're gonna simply follow the points to curve it and with the parabola. Step 6 and label. That's it. We're gonna label it and we're gonna proceed to example 2. We're just gonna make this to determine the direction. So we're just gonna divide both sides by 4 and p equals negative 5. So the opening would be downward. So because of the first term is x. Step to identify the vertex, negative 2 and 3. Every focus and we're gonna look here to negative 2 and negative 2. The latus rectum is negative 12 and 8 and negative 2. So that is the latus rectum. So we're gonna plot the vertex and the other points here. So negative 3 and negative 2 and 3. So draw the parabola and last step is label. That's how we plot a parabola. This lesson will be easy if you really understand it.
In this lesson, we're going to have to focus on hyperbolas. Now this guide will explore the essential features of hyperbolas that you need to focus on when analyzing or graphing the conic section. What to look for? First, we have transverse axis, or A. The transverse axis is a line passing through the foci of the hyperbola. Joining the vertices, it represents a major axis of the hyperbolas and is the key to understanding its shape. And the second one is the conjugate axis, or P. This is the line segment that is perpendicular to the transverse axis. It serves as the minor axis of the hyperbolas, bisecting the transverse axis at the center. Third one is the foci. Foci are the 2 points on the axis of the hyperbolas that is equidistant from the center. They are critical in defining the shapes of the hyperbolas and are used in the standard equation. So how to get the value of c? So we have the formula c is equals to the square root of a squared plus b squared. Now I have a first example. It's x squared over 9 minus y squared over 16 equals to 1. So let's proceed to step 1. First, we need to determine whether hyperbolas is horizontal. In this case, our a squared is under x squared, so our hyperbolas is horizontal. And for step 2, identify the center. The center of this hyperbolas is 0, 0, or the origin. Step 3, find the values of a, b, and c. Our a is 9. Let's square root it. So our a will be 3. And for b squared is 16. Let's square root it. So we will have 4b. And for the values of c, we will use the formula c is equals to a squared. And for the values of c, we will use the formula c is equals to square root of a plus b squared. And now we have c is equals to b squared, 25. And now, The square root of 25 is 5, so RC is 5. For step 4, let's plot the center and the other points. Since RA is 3, let's count 3 units from the center horizontally, and count 4 units vertically since RP is 4. Now step 5, let's draw the rectangle. And step 6, let's plot the asymptotes, which is the diagonal. And for step 7, let's draw the hyperbola. And step 8, label them.